This week we're going to talk about software. We're going to talk about the different types of software. So our objectives are, what are the fundamental categories of software and their relationships? What is an algorithm? How does that relate to software? Compare and contrast a PC application versus a web application. The role of the operating system. How files are organized. We have those already now within our computers. The evolution of interfaces from text to GUI interfaces. Some challenges of intellectual property, patent law, copyright. So let's start with processing. Software enables people to communicate. We already know this, okay? Software makes it possible for people to communicate systems back to people. These seem silly. But this is an important one. An algorithm is a set of step-by-step procedures for accomplishing a task. So an algorithm is actually, when I think about coding, it's actually the steps that you use to tell the computer how you're going to do something. When you code, you have to be so clear. You have to be able to say, open the file, retrieve the file, open the file, store the data. You have to tell the computer every single thing to do. The computer doesn't know how to do anything unless somebody has created an algorithm or a code. So the programmer's job is to actually create this task list into code. Okay, compilers. What happens is there is a device, it's a software that takes a programming language and converts it into something that is machine language. So for example, if you're coding in Java, most likely there is a Java compiler somewhere that takes the Java code and then converts it to something that the computer then can read. When I coded in the day of COBOL, I would have to write in COBOL code, which was not very user-friendly at all, and run it through a compiler. The compiler then would identify all of the different errors. It was mostly syntax errors, and syntax errors are errors that they're not logic errors. So there's two types, syntax and logic. Syntax is, hey, you just did not code this right. So for example, I'm teaching an HTML class, and if you don't put the HTML slash in the right place, it doesn't display properly for our website, for example. So compilers take the code and translate it into machine language, and it really only looks at syntax, not logic. It doesn't determine is the code doing what it's supposed to do. It's just saying, is the code something that the machine language is readable. Okay, software applications. Word is one, TurboTax is one. HR payroll systems are one, inventory management systems one. When you order over Amazon, that's one. And system software. I think of that as the bridge between the application software and the actual operating system of the computer. And we'll go into more detail later. Okay, remember, a computer is nothing more than on and off electrical impulses, on and off switches, zeros and ones. So it's really about just performing basic mathematical operations. To get it to do logic, though, that's where it becomes more complicated. And the more sophisticated the language is, usually then it requires, it's more word-like, English-like, and there's usually fewer lines of code you have to write, but each line of code means a whole lot more of machine language. This last sentence, computers seem smart because they perform these operations quickly and accurately. Only if they're coded that way. Okay, remember, a computer is nothing more than what you code. Now, there are computers now that are actually learning from themselves, and that's artificial intelligence that we'll get to later on. Okay, every computer processes instructions in machine language, like I talked about before. And that's that very basic operation, zeros and ones. Adding and subtracting, comparing numbers. It's all about numbers. High-level languages like C++, Java, Visual Basic, you can get more things done by writing less code, and it's more English-like. Okay, executing a program. So what you do is you write the code, and then you run it through a compiler, and the compiler looks for syntax errors. That means just errors in how you coded it. It doesn't look to see if it is actually doing what you said it would do. And it's saying most programs are composed of millions of simple machine language instructions. That is really true. So when I would write programs back in the day in COBOL, I might get, 40 or 50 errors for a simple file update program, because maybe I didn't define my file right, maybe I didn't define my data right, maybe the data that I was moving into a particular field wasn't compatible with that field. There's all of these things that have to happen behind the scenes for these instructions to work. And there's something called a program counter inside the CPU, which keeps track of the address of all of the next instructions. It's pretty amazing. And the instruction execution cycle has 3 steps. First, it fetches the instruction. Then it increments this counter saying, I'm at this instruction. And then it performs the specified task. That will be on the quiz. Software applications for users. Okay, we are become so accustomed to just being able to pick up a piece of software, get an app, do whatever we need to do very easily, go to the web and just find something for whatever we want, whether it's directions, MapQuest, whether it's finding a gas station, whatever it might be. These applications have become easy, but there was a time when every application was very complicated and you didn't have access to these applications. And it wasn't that long ago. I'm not that old. Anyhow, so right now we have all these different types of applications. Games is one type of application that has really pushed some of the affordances of what the computer can do, because it's expanded virtual reality, it's expanded augmented reality, it's used all kind of new GUI interfaces, it's got animation. Games really pushed us into ways that now are part of business applications, which is interesting. Okay. Consumer applications, updating, compatibility. Okay, so this is an important point, licensing. When we buy software, we're buying a software license. We're really not owning the program. That's why, for example, we buy a license to Windows. We get the code, but that code is only good for as long as other software will be compatible with it. You're just getting a license. There's some software that's called public domain software, which you don't have to pay for, or shareware, which is which is stuff that we can share among others. All right, and you don't have to pay for. Education software is very common to find that to be shareware type of stuff. Web applications. Now, okay, so here's a difference now. A web application doesn't require us to have any kind of software on our computer. Instead, a web application has got the software installed on internet servers somewhere in the web, and we log on to the web, we go onto that internet server. None of the code is on our machine. It's on somebody else's machine. So Google Docs, web mail, some of the multi-games, if you've played any World of Warcraft, for example, pretty amazing. Wikis, Amazon, all these types of applications are on the web. You're seeing more mainstream applications go on the web. So for example, in my hospital that I used to run, people would have to go to actually a time card, and they would have to go to the time clock and enter their time. But now what people are able to do is they can go to their computer, they log on to a virtual time card, and they enter their time there. It's time-stamped by the time and the place where it was, because if you needed to be in a certain place, it would log on with the IP address as well as the time to verify you are where you need to be at what time. Okay, mashups is continuing to grow as a big area, where you have a piece of software in multiple places. So you might have, and it might be bringing software together from multiple places. So for example, I like to think of my, I have a friend, and he's doing a project right now where he is going to identify all of the places within Fairfax City where the sidewalks no longer are ADA compliant, meaning that they have holes or things that are not suitable for people with disabilities. So in order to do that, he needs to have access to lots of different things. He needs to have spatial mapping to be able to understand the sidewalks. He needs to have access to a tracking system to be able to track where in the sidewalks, there might be problems. He needs to have access to some other types of demographics. So all of these pieces of information are put together in a single place to be able to provide the information. You know, Google Maps is a perfect example of that. Another example is a Google map that has, if you've ever seen, like, you see a Google map and you see like crime statistics, like where are the most crimes given a Google map, because it's integrating crime statistics with a location. It's called a mashup. Vertical markets, medical billing, our EMR that we talked about last week. Okay, system software. This is very important. It's a class of software that that includes the operating system and utilities. So what would be some utilities? Defrag might be one of the utilities it uses. Formatting might be one. We no longer format disks. We don't have to do that anymore. It's just kind of done for us automatically. But there was a time you had to format the disk, meaning you had to identify the location. You would create the location, an address on each place of the disk, so that data could be stored in it. Okay, so system software is what communicates with the operating system. All right, what the operating system does. This is very important. It keeps your computer running efficiently. But what it really does is it maintains the file system. Where are the files? It does the addresses. It allows multitasking. So for example, if you've ever had a situation where you have to go out to a file to get information, but at the same time it's doing some kind of processing, multitasking, while one of the disks is going out to do something, like gather information, a task is being performed by another command. So the operating system is managing all of these tasks and giving them priorities, and it manages them in virtual memory. Virtual memory, the same as RAM. And operating system runs continuously when the computer is on. As soon as the computer is turned off, though, the operating system stops. So computer usage. Computer user, here I am. The application program wants to do something. The operating system is communicating with the hardware. So, for example, application program. TurboTax, let's use that. TurboTax, you're entering information. It needs to go and be filed somewhere. You're storing your file after you've done. The application program calls the operating system, and the operating system identifies where the operating system actually will then store the file in the location you've told it to do. Okay, on your computer hardware or a virtual drive. Utility programs, copies between storage devices, repairing files, viruses, and I just moved that by accident. Anyhow, device drivers. We kind of talked about the peripherals before. Many peripherals are bundled. We already kind of talked about that. Operating systems of life. Remainder of operating system is loaded during the booting when the computer is turned on. So remember, some computers, almost all computers, store operating commands in ROM. It's in their BIOS, B-I-O-S, if you ever see that word. It has that boot drive that is the necessary piece of information to really get your computer system to go up. When you can't get the boot drive to emerge when you turn it on, never a good sign. Okay, so then the boot drive brings up just enough so then it can trigger your operating system, your Windows, your El Capitan, your Linux, whatever it is, to actually load. All right, so here's some information about this, and this you can look at this and more later. Our RAM, our OS, our operating system, our CPU, these are all the parts that we talked about. So the CPU automatically begins executing commands stored in ROM. Okay, the operating system loads from disk into the system's memory. So, this is a key thing. To avoid losing data when the system is turned off, save it to the disk. That just makes sense. But how often we don't do that. Okay, user interface. How do we react with the computer? So right now we're very used to like mouse-driven. Touch has become very important. But it's how we actually tell the computer a command. There was a time that everything had to be text and it had to be very cryptic. But now as we go to higher levels of machine connectivity, we no longer have to use as many commands to do the same thing. MS-DOS was command line interface. I mean, you had to write open, close, file, save. You don't do that anymore. Unix. Now, an interesting thing about Unix, and it was developed at universities, is it because it was really an open source. It didn't want to be proprietary. Like Apple and Windows is pretty much proprietary. You have to have an operating system for Apples. You have to have an operating system for Windows. But Unix is command line based. But what it is most important is it works with all sorts of computers. It works with Sun computer. It can work with a Windows computer. It can work with a Mac computer. And it's very strong. And Linux is a Unix clone, and it's distributed for free. So Unix was actually IBM, but I lied. Unix was HP, it was IBM, it was all different types, but it was a command line, bigger computer. Usually a Unix box would be like a server that was much bigger than a smaller computer. But Linux was the preference among universities because it was supported free and more open source. When good software goes bad, restart the application, you know that. Recover your work, not always. Reboot the system, then you've lost the work most generally. Recheck for updates, sometimes that works. Rebooting in safe mode means that it goes back to a previous version of your software. Reinstall the program. You know, a lot of times when software goes bad, it's because of a virus. So these are just some software platforms. Windows 10, introduced in 2015. Microsoft skipped version 9. SQL Server runs on small servers. It's these are different types. Windows Phone for the mobile devices. El Capitan for the OS for Mac. So these are just some other ones that you can look at. BlackBerry was very BlackBerry is the perfect example of a company who had it all and didn't keep up with what was happening because it was not a visual system. It was a text-based. Didn't keep up, and the smartphones came out and it just lost all of its market share. All right. Operating systems design and run a platform. So Linux OS or Linux apps, Mac for Mac OS and Windows. I mean, that's pretty easy. You all know this. File management, where's my stuff? You know, there's a hierarchy. You usually have like your C on your PC, you'll have your C drive, and under your C drive you might have several major files under that. It could be documents, pictures, whatever, and then you can create your own hierarchical file structure. The key here is they use a hierarchical file structure. So it's not a relational database. All right. Folders may be placed in files. Every file and folder has a unique path name, and you already know that. So a lot of these things you know because you've been doing file management, utilities like deleting files, copying, moving. You know, right now we're so spoiled we just use a right click to be able to do a lot of those things. All right, managing. These are all things that you would know, and you can look at these more later. Disk formatting. It's being done automatically now. You don't really have to do too much with it. But just to know that your disks are divided into a series of tracks, just like a track. And within the tracks, there's something called sectors, like they're just pieces, like pieces of a pie. And within sectors are clusters or blocks. Why is this important? Because when you're saving information on your hard drive, there was a time when hard drive space was very expensive. So you wanted to maximize that space as best you can. So in order to be able to do that, you wanted to be very, you would defrag your hard drive to be able to get rid of these blocks of space that you weren't using. Because what would happen is the computer would take, depending upon the size of something you're storing, it would look for that size. So if you had something that was bigger than the next block available, it might totally pass it. Or if you deleted information or files, it wouldn't fill them into those spaces. So clustering things together would then free up space for putting new files into it. And this is defragging. This is before, and see, as I'm talking about this, you can see that you've got bits and pieces all over the place. And the thing is, these pieces of data might all be related. So they would have put a piece here, a piece here, and a piece here. Well, what happens? It just takes longer to get the whole file or all of the data to come together. But if you put all of the blue, all of the data that is associated with each other together, what happens? It's faster. Faster because it's contiguous. All right. Okay, software piracy. This I thought was pretty interesting. Do you know that 1/3 of all software is pirated? Interesting. And that's illegal duplication of copyrighted software. So that means if you had a bootleg copy of Microsoft Word, for example. Nowadays, few people companies have gone away from physical disks. Instead, they have a license. The thing is now, every time you log on, they have something that actually tracks your license, and they know whether you've tried to load it onto another machine. It's a little scary in a way. Somebody's always watching. Software industry loses billions of dollars every year to pirates. 1/3 is illegally copied. There you go. Piracy is particularly hard on small companies, startup companies. That's a big problem. And they're the highest in developing countries. Why? Because people in developing countries have no money, and they might have a lot of time to try to figure out how to steal it. So intellectual property. Intellectual property is the rights of the intellectual. So if you create something, if I created a piece of software, it would be my intellectual property. It was my intellect that created it. So intellectual property laws protect that. Copyright would be like if I wrote a book. Trademark, if I had a symbol. Patent, if I created a device. Usually it's a device. But patents can go for ideas too. Remember, it can go for ideas. And contract law covers all sorts of things. So that's pretty much it. We talked about the types of 3 main categories: translator programs. I talked about those compilers, applications, and system software. Differences between the web and your PC. The web, internet, it's the internet, and servers are on the internet, not on your PC. And you can look at the rest of these later. I won't trouble you. But this should give you a high-level understanding of what we're talking about when we talk about software. So hopefully you've enjoyed this lecture. If you have any questions, you have any feedback, get back with me. Thanks so much, and have a wonderful rest of the week. Talk with you soon. Bye-bye.